time we had considered some operations on the list, starting with some merging of lists, then union, intersection and whatnot. Today we will go ahead with one operation, write down, to reverse the linked list. That was one which is pending last time. To reverse the linked list. It is not going to be the value wise reversing like we did in case of arrays. In case of arrays, we used to pick up the value at the last position and put it at the first position. So we are not going to do that job, like picking up the value of the last node and putting it in the first node. Instead of that, we will remove the last node and that should become the first node in the list. Okay, so we are not interested in the values getting arranged once again, but it will be the node sequence. Nodes are to be arranged in such a way that every node which is pointing to its next node should now start pointing to its previous node. Okay, so we will never compare any value. It is not position oriented. The entire node should be detached and again attached to the appropriate place. For example, if the list is, say, H pointing to 11, then 32, then 65, then 30, then 23, then 19. Suppose this is the list. Then when we reverse it, we want 32's next, this node's next, to point to the node which contains 11. Got it? Next of 65 should point to 32. And ultimately header should point to the last node. Okay? So we want to just arrange it in that manner. The first way in which it can be done is, this was the given list, 11, 32, etc. I will create one more header, say H1. Job will be to delete the first node from here, remove the first node. It's not to free, but just detach it and attach it after H1 and set its next to null. First step. Okay, so once you do this job, for the second time, the list, first list will be starting with 32, 65, etc. because node 11 is removed. Second list will have node 11 into it. Job is the same way. Detach the first node, so remove the first node and add it at the beginning. So H1 arrow next should point to 32 and 32 arrow next should point to 11. Third time, the original list now will have first node as 65, then 30, then 23, etc. Second list will have H1 pointing to 32, pointing to 11. Again, detach the first node and add it at the beginning. So H arrow next will point to 30, 23, 19, whereas H1 arrow next will point to 65, 32, 11. And you will in a way find that this is getting reversed. I am detaching the first node and adding it at the beginning. Keep on doing this till the first list gets empty. Keep on doing this till the first list gets empty. So when the last node is removed, then H arrow next will become null. Then you stop. But only problem over here is we have created header 1, H1, whereas the original list should have been reversed. So at the end, the picture would have been H arrow next is null, whereas H1 arrow next is pointing to 19, 23, 30, 65, 32 and then 11. This is the situation at the end. Now you just set H arrow next to H1 arrow next. So you are connecting the entire list at the next of H first given header and free H1. And you will find that the list is reversed. Only thing is we have generated one node, H1. We have freed it also. Okay. If they exclusively say that without generating any node, then we will have to again think about the same algorithm as how it is to be implemented. So the reversing in this manner can be performed, see, like this. Reverse, see it first, SLLP H. It is SLLP temp, comma H1. Temp will be the node which will be detached. Okay, and should be added at the beginning of second list, H1. H1 is the new node that I am going to generate. Temp will be set to, one second. Temp will be set to H arrow next. So this is going to be node temp. Now when you want to detach this temp, then you will have to simply say that H arrow next should point to temp arrow next. So H arrow next equal to temp arrow next. Node gets detached, first node. Should be attached after H1. After H1, add begin के जो दो steps थे वो. Like temp arrow next should point to H1 arrow next, and H1 arrow next should point to temp. First the forward link and then the original one. So there will be two more steps. Temp arrow next should point to H1 arrow next, and H1 arrow next should point to temp. So this attachment has been done. ये तो हमने पहले ही निकाला था, right? And then repeat. कब तक? जब तक H arrow next null नहीं होता. So we'll say that while H arrow next is not equal to null, keep on performing these four steps. First two will detach the node, next two will add it at the beginning. Okay, so now H1 arrow next will contain the list which is reverse of the original. Now we have said that H arrow next should again point to H1 arrow next. H arrow next should again point to H1 arrow next, and then you will have to free H1. That will be our function reverse. A simple job, two-step algorithm. Detach the first node and add it at the beginning. First list से एक एक node, beginning का node detach करना है, and second list में beginning में ही add करते हुए जाना है. These two will detach. Temp will be the first node of this list. H arrow next is temp arrow next. Will detach that node from the first list. And in the second list it should be added at the beginning. These were the two steps in our add begin. And the list will get reversed. Make a note. Two-step algorithm, detach first node and add it at the beginning in the second. Only thing is we are generating one extra node which we are going to set free also afterwards, but sometimes even that will not be allowed. The second algorithm for the same, for reversing, it will be called as the 3-pointer method. I will have temp1 initially at the header, temp2 will be the first node, and temp3 pointing to the second node. So I am keeping the track of the current node. Temp2 is always my current node. Temp1 is its previous and temp3 is its next. So I am keeping the track of which is the previous node, which is the next node. Now I can safely say that temp2 arrow next should point to temp1, which was otherwise pointing to temp3. So the current next will be set to the previous one. So I will have to start saying that temp1 equal to h arrow next, temp2 is equal to temp1 arrow next, and temp3 equal to temp2 arrow next. That is the initialization part. Then you are going to reverse. You will have to say temp2 arrow next should now point to temp1. एक revert कर दिया. Now temp1 should go to this position, temp2 should go to the next, and temp3 should go to its next. क्योंकि temp1 को आप temp1 arrow next नहीं कह सकते. That's why I am keeping all the three. So now in the second step this will become temp1, this will be temp2, and this is going to be my temp3. So it is just reassignment. So I will have to say after this, temp1 goes to the position of temp2, temp2 goes to the position of temp3, and temp3 advances to its next. And again repeat. Again you set temp2 arrow next to temp1, this will be broken. Again you advance, temp1 will come to the position of temp2, temp2 will go to the position of temp3, and temp3 will advance by 1, temp2 arrow next is temp1. Got it? Now if I advance it once again, so this will become temp1, this will become temp2, and temp3 will become null. But even if temp3 becomes null, I can still say temp2 arrow next is temp1. Okay, so यहाँ पे temp3 null हुआ था, but I am still going back and setting temp2 arrow next is temp1. Temp1 becomes temp2, fine. So temp1 will now come to the last position. Temp2 goes to temp3, so it becomes null. Whereas temp3 cannot advance because it is already null. So I will have to keep a track whether temp3 is null or not. So I will just put a condition if temp3 is not equal to null, then only you advance it to its next, because otherwise there will be error while dealing with the last node. Okay, and so when temp1 reaches last node, temp2 becomes null and temp3 will not advance, temp3 will also remain null. At that time we should stop. So I will say that keep on doing this job while temp2 is not null. When temp2 becomes null, stop. Okay, temp3 तो उस वक्त null होगा ही. Now what is the situation? Last node is pointing to previous, this node is pointing to node previous to it, etc. Only thing is first node is also pointing to header, which should not happen. Secondly, header should point to the last node. So I will have to set this like, and I know that that position is temp1. I know that that position is temp1. So I can say h arrow next equal to temp1. But before that, right now h arrow next is pointing to the first node. So I will go to this node and set its next to null. पहले इसे null बना देते हैं. Otherwise वो open रह जाएगा फिर. Okay, like we close the string. So I will say h arrow next is equal to null. ये मैंने first node का next null कर दिया. h arrow next will take you to this node. उसका next जो है वो अभी header को point कर रहा है. Instead of that, make it null. And then you set h arrow next to temp1. And the list will be reversed. Here we have not generated even a single extra node. एक भी node generate नहीं किया इसमें. Okay. So this is going to be again a void type reverse, to which I am going to pass SLLP type H, and you will have the declaration for temp1, temp2, temp3, and no return. This condition is important, otherwise एक node attach नहीं होगा या फिर run time error आएगी. Condition is when temp2 becomes null, we should stop. Okay, make a note. Explain it properly in steps. It is 3-pointer method. Now single linked list has got a drawback that once you take a step ahead, you cannot come back to the previous node. But if the application is such that you are required to travel in both the directions, sometimes in the forward direction and sometimes to the previous node, then it will be essential that we should keep the track of where is the previous node. And in that case, the picture will appear like this, that every node will have a pointer pointing to the next node as well as the previous node. And of course, this being the first node, this should be null. This is my header. In general, the node will be represented as it has got a pointer to the previous node, data, and pointer to the next node. Conventionally, we are showing it like this. Okay, this is pointing to this. It is not pointing to next position. It is actually pointing to the node. It is not pointing to the previous. मतलब ये arrow यहाँ पे आ रहा है. It doesn't mean that it is pointing to the next field. To be precise, the figure should have been drawn like इसका जो नेक्स्ट है is pointing to the beginning of this, और इसका जो previous है that is pointing to the beginning of the previous node. Pictorially हम ऐसे दिखाते हैं. Okay, because I have seen students who are unnecessarily saying that some node, suppose this is temp, so temp arrow next, मतलब ये node, उसका previous should point to temp arrow next. ऐसा नहीं होता, ये next position नहीं है, it should point to the previous node. Correct representation should be like this. Conventionally we show it like this. Or you can even have the example like, suppose this is header having address say A100, then I have another node having address say A224. I have one more node having address as A320. I have one more node whose allocated address is A122. So H arrow next will contain the address of the next node, that is A224. So this becomes the first node, and this being the first node, its previous is none. Suppose the second node is this, so iska next will contain the address of next node A320. Iska previous will contain the address of the previous node A224. Iska next will contain the address A122. 122's previous will contain this address A320, and next is none. This is how it will be linked internally. Now observe that we have said that it should be possible to travel in both the directions. We are still using H arrow next to go to the first node. We still have one more pointer with the header, which is previous. Let that previous point to the last node. So H arrow previous will contain A122. So that if I travel from previous, then I can go to the last node using previous to the previous node, previous, and it's when previous is null, stop. That will be the last node when you travel in the reverse direction. So this is the pictorial representation. This is how the node should be. This is the correct way of drawing the figure, which we will not be drawing in this manner. And this is how it will be stored internally. Got it? Now, the structure for it. It is going to be type def struct. क्या लिखूं? What should I write? Not double because it is keyword. In data, and it will be struct doubly star previous star next. Now if you see this representation, then the picture is not like this, actually. Okay, by the meaning, by the definition of structure, first field data, second field previous, third field next. Okay, it will maintain the sequence internally. But still we will draw figure in this manner, we will declare it in that way. उससे कुछ फर्क नहीं पड़ने वाला. Okay, and I will declare the new type as a pointer type DLL. Obviously, the very first function will be get node, where we are required to perform the allocation job. It will be n equal to typecasted as DLL, malloc size of struct doubly, and then both the pointers should be set to null. N arrow previous equal to null, n arrow next equal to null, and return n. In the previous case, I had declared SLL as the type. It was not a pointer, it was a variable, and so I had to declare one more SLLP, which was pointer type. Now I am not doing that job twice. I am directly declaring it as a pointer type. So we won't have DLLP, we will use it as DLL. This is get node. Okay, we have said that whenever memory is allocated such that it is going to contain some address, we are required to, after allocation, set those two addresses as null to avoid the access to the memory which is not allocated, because otherwise that particular next and previous might contain some bit pattern which can be interpreted as address. That should not happen. So it is always safety that we should set next and previous to null. Okay. Now have a look at the create list function, the one which we have written in the linked list. The create list function that we have written in the linked list. No, null. If you observe the create list function, I have started with allocating the node for the header. So h equal to get node, that will remain as it is. Then we generate a new node n, we accept the data, and then we have said, and temp was set to h initially. So we have said something like temp arrow next is equal to n. So this was temp and the node is attached after it. So the picture, whatever is our temp, जिसका के next null होता है पहले, we generate a new node इस तरह से. We have said temp arrow next is equal to n in singly linked list. Now in doubly you will have to also say after that n arrow previous equal to temp. Okay, so only just mark that, don't write anything over there. एक statement वहां पे add होगा आपका, and you will continue. Every time new node is added at the end, so temp arrow next equal to n तो करना ही पड़ेगा. N arrow previous equal to temp will be one more statement that you will have to add in that create list. And then see at the end क्या होता है. At the end जो यह भी कह रहा था कि जब ये first node attach होता है तो this was temp, this was n, so n arrow previous is still pointing to header, जो कि हमने कहा है कि होना नहीं चाहिए ऐसे. First node का previous should be null. So after you complete the loop, that is when user says no, उसके बाद you will have to say that h arrow next, जो कि first node है, okay, उसका previous अभी header को point कर रहा है, so set it to null. So h arrow next arrow previous equal to null is one more statement that you will have to add after the loop, so that first node का previous will point to null. And finally header का previous should point to the last node. What was the last node? That was the one which we have just attached, n. Okay, so one more statement and you will have to set h arrow previous equal to n, these two, and then return h. That will be our create list function. Okay, huh. So header will contain the addresses of both the ends, first end as well as last end. Then we had a function, huh? हाँ, नाही सांगणार, कारण हे काय नवीन नाहीये. हे गेल्या वेळेला स्ट्रक्ट सिंगली मध्ये तसंच केलं होतं. तेव्हा नव्हतास का तू? मग काय करणार आम्ही त्याला? रॉंग टाइम स्टेटमेंट क्वेश्चन्स कॅनॉट बी आन्सर्ड. असा प्रश्न जर का असेल तर तो त्यावेळेलाच एक्सप्लेन केला होता की हे काय आहे. त्यामुळे जाऊ द्या, दांड्या नाही मारायच्या, मी ते केव्हाच सांगितलेलं. बाकी कोणाला हा प्रश्न आहे का? स्ट्रक्ट डबली काय आहे ते? It's not a structure declared inside a structure. We are just saying that the two pointers are pointing to the node or pointing to the memory location where the node of struct doubly type will be stored. It's not a recursive definition or anything like that. Anyway, so three statements to be added to create list, and you will create, and of course the return type will be DLL. Temp, n and h you will declare it as DLL type. ओके, वो चेंजेस आपको करने होंगे. सी द सेकंड फंक्शन, दैट वाज प्रिंट लिस्ट. प्रिंट लिस्ट ऑफ सिंगल लिंक लिस्ट. प्रैक्टिकली नो चेंज. फर्स्ट नोड हेडर प्रिंट करेंगे, फिर फर्स्ट नोड, फिर सेकंड, फिर थर्ड. ज्यादा से ज्यादा हमारे प्रिंटफ में ऐसे एरो था, अब हम इसे ऐसे बताएंगे बस, बिकॉज एवरी नोड इज पॉइंटिंग टू नेक्स्ट एंड प्रीवियस था. हाँ, ज्यादा से ज्यादा इतना चेंज, अदरवाइज दैट प्रिंट लिस्ट विल वर्क एज इट इज. क्या फर्क पड़ता है? यू आर स्टार्टिंग फ्रॉम हेडर एंड गोइंग टिल द एंड, लास्ट एरो नेक्स्ट इज नल, फाइन. एक और फंक्शन लिखना पड़ेगा आपको, दैट इज गोइंग टू बी प्रिंट इन द रिवर्स डायरेक्शन. लास्ट नोड पहले प्रिंट करेंगे, फिर उसके पहले वाला, फिर उसके पहले वाला. इट विल बी द सेम प्रिंट लिस्ट फंक्शन, बट इंस्टेड ऑफ स्टार्टिंग विथ टेम्प इक्वल टू एच एरो नेक्स्ट, start with temp equal to h arrow previous. Okay, and then instead of saying temp equal to temp arrow next, say temp equal to temp arrow previous. You will start moving in the reverse direction. And of course first arrow previous is null, so the same loop, same condition will work. That's why I have set the first arrow previous as null, so that we don't require more modifications. Otherwise इसमें आपको लिखना पड़ता था कि temp arrow next is not header or temp arrow previous is not header. ऐसा नहीं करते. Will set first nodes previous as null, right? तो हमें पता चलेगा कौन सा है. So that was one more function which we will have to write, print in the reverse. उसके बाद था search. No change in that. Search function में कोई change नहीं होगा. You will keep on checking first position, second value check करते जाएंगे. Wherever value matches, you will return temp. Otherwise at the end you will return null. No change in the search. What about function append? उसके बाद append था. सर्च के बाद append ही था ना? या append में पहले एक लूप है हमारा. We have started with temp equal to h arrow next, and while temp arrow next is not equal to null, temp equal to temp arrow next. ये किस लिए कर रहे थे हम? So that we wanted to reach the last node. अब डब्ल्यू लिंक लिस्ट में लास्ट नोड तक जाने के लिए ये सब कुछ नहीं करना पड़ता, बिकॉज यू विल इंस्टेड ऑफ दैट एंटायर लूप यू विल जस्ट सेट टेम्प इज इक्वल टू एच एरो प्रीवियस. सो यू विल बी एट द लास्ट नोड. एन इक्वल टू गेट नोड, एक्सेप्ट द डेटा, टेम्प एरो नेक्स्ट इक्वल टू एन, ये वहां भी है. सिर्फ एक और स्टेटमेंट आएगा, एन एरो प्रीवियस इक्वल टू टेम्प, क्योंकि जो नया नोड अटैच किया है उसका प्रीवियस लास्ट नोड को पॉइंट करना ही चाहिए. So in general, for append, you will have to start with saying temp equal to h arrow previous, then n create वगैरह करना वो सब काम. Then you will say temp arrow next equal to n, as well as n arrow previous equal to temp. और एक काम करना होगा, ये तो नया नोड ऐड हो गया एंड में. There is one more job which is to be done. क्योंकि अभी जो नया नोड अटैच किया है that becomes the last node and h arrow previous should point to that. Okay, so you will have to have one more statement, and h arrow previous is set to n. Append function which does not have any loop. Now सिंगली लिंक लिस्ट में append में loop था to reach the last node, अब जरूरी नहीं है. Okay, so in the remaining time today you are required to write all these functions. वहां चेंजेस नहीं करने, वो फंक्शन देखना है और डब्ल्यू लिंक लिस्ट के लिए लिखना है. गेट नोड मैंने दिया है, इसके बाद क्रिएट लिस्ट, क्रिएट के बाद प्रिंट लिस्ट, फिर प्रिंट रिवर्स, देन सर्च में कोई चेंज नहीं है लेकिन फिर से लिखना होगा आपको, एंड देन अपेंड. राइट, क्रिएट में 3 स्टेटमेंट्स ऐड होंगे, प्रिंट में कोई चेंज नहीं है, प्रिंट रिवर्स में प्रिंट ही लिखना है लेकिन नेक्स्ट टू बी रिप्लेस्ड बाय प्रीवियस, सर्च में कोई चेंज नहीं है, अपेंड में लूप जाएगा, लूप के बजाय टेम्प इक्वल टू एच आरो प्रीवियस आएगा, नोड क्रिएट करेंगे, एक्सेप्ट द डेटा, उसके बाद टेम्प एरो नेक्स्ट इक्वल टू एन स्टेटमेंट वहां भी है, हमें सिर्फ प्रीवियस का ऐड करना पड़ेगा जो हमने पहले भी क्रिएट में भी ऐड किया था, एन एरो प्रीवियस इक्वल टू टेम्प. और लास्ट नोड जो अभी हमने ऐड किया, दैट इज द नोड विच शुड बी पॉइंटेड बाय एच आरो प्रीवियस, दैट शुड बी डन. there is no return with that particular append. Correct? देखो. And then if you get stuck up, ask me. Refer to the previous functions and write them again. पहले structure, फिर get node, create, print, print reverse, search, append. क्योंकि इसके बाद जो है insert, delete, उन सब के लिए मुझे बताना पड़ेगा क्योंकि उसमें लिंकिंग का प्रॉब्लम है. यहाँ तक तो स्ट्रेट.